Hello, Mr. Price here, and this is the final video of the January 2007 Mechanics 2 paper, and this is our one and only projectile question in this paper. Let's take a look. Okay, a missile is projected with initial speed of 42 meters per second at an angle of 30 degrees above the horizontal. Ignoring air resistance, calculates the maximum height of the missile above the level of the point of projection. Okay, it's probably worth noting this probably isn't a military missile. It's a missile just is a word for any thrown object. So we probably want to think, okay, there's no actual force projecting this thing forwards. It's just given initial velocity and that's it. So don't get confused in that sense. There's no force acting on it other than gravity. So, like with all projectile questions, there's going to be no force acting on it in the horizontal plane and only gravity in the vertical plane. So, my missile starts at this position and it's projected at 42 meters per second at an angle of 30 degrees. Okay, so we want to find the maximum height of the missile, the maximum height. Okay, so resolving upwards, we know its initial speed is 42 sine 30. At its maximum height, it will have no more vertical velocity, and gravity is acting against the speed, and we want to know its maximum height. So v squared equals u squared plus 2ax. 0 equals 42 sine 30 squared minus 19.6x. So working that out, you should get a value of 22.5 meters. Okay, that's part I. Okay, for part 2, we now want to find the distance of the missile from the point of projection at the instant when it is moving downwards at an angle of 10 degrees to the horizontal. Okay? So what we really want to do is find its horizontal and vertical coordinate of when it's moving at this particular angle. Okay, and to do that, we are going to need to do a bit of resolving here. Okay, if we resolve this way, we can get the speed in the x direction as 42 cosine 30, and this gives us 21 root 3. So what's going to happen is it's going to be travelling this way and downwards, because the question specifically asked for downwards, and its angle here is going to be 10 degrees. So we know this is 21 root 3, so we can work out this value now. So using tangent 10 equals opposite over 21 root 3, we get this value to be 6.414 meters per second. Okay, so now we know that the speed it needs to be travelling in. We want to find its distance travelled. Okay, so we're going to need the time at which it's at this particular position. So let's resolve upwards. So we have an initial speed of 42 sine 30, and actually sine 30 is just half, isn't it? So it's going to be 21. The acceleration is minus 9.8. The velocity, we want it travelling downwards, so it's going to be negative 6.414. And we're going to want to know the x value and the time, so that we can work out how far it's travelled in the horizontal plane as well. Okay, so using v squared equals u squared plus 2ax, you should find that it's got an x a displacement in the horizontal plane, vertical plane, as 24.59 meters above the surface. And then using v equals u plus at, you should find that this is a time of 2.797 seconds into its flight. Okay, so now resolving to the right, we know that distance is speed times time, and our distance here is 21 root 3 times by 2.797, so it travels a horizontal distance of 101.735. So now, if this is our point of projection, and this is where it is now, we want the distance from its point of projection. So it's travelled 101.735 metres horizontally, and it is 24.59 metres above the surface. So using Pythagoras, you should get a distance of 105 metres. And that is question 8, fully finished. Thank you.